Hi there. Today we're going to be talking about simplifying fractions or reducing fractions to lowest terms. We're going to be tying in with something you learned last year in fourth grade to help us get a strategy that works well and is efficient. We want to work smarter, not harder, when we're doing these different interactions with fractions. So I want you to think back, and you talked a lot last year about prime numbers. And remember, a prime number is a number that only has two factors, 1 and itself, meaning the only way to get that number as an answer in a multiplication problem of whole numbers would be 1 times that number. Like 3 is a prime number because the only way you can get 3 as a product of whole numbers would be 1 times 3. 11 is a prime number. The only way you can get 11 as an answer or a product of whole numbers would be 1 times 11. So the first thing we're going to talk about today is called prime factorization, which directly links with the understanding of what a prime number is. Prime factorization is a string of prime numbers, so a whole bunch of prime numbers only that answer a given product. So let's look at the number 12. And we'll start off with, we want to find the prime factorization of 12. So what's one multiplication fact that equals 12 besides 1 times 12? You could do 3 times 4, sure. Okay. As soon as you have a prime number at the end of one of your strands here, you're going to circle it. Grow an apple. Okay. Is 4 prime? No, because what equals 4? Right, 2 times 2. Is 2 prime? Yep, grow an apple. Is 2 prime still? Yep, grow an apple. So now at the end of all of our strands here, or our branches, we have prime numbers. So the prime factorization for 12 is 3 times 2 times 2. All right, what if there's somebody out there that said, but I wasn't thinking 3 times 4. I was thinking something else. Well, let's try it. Let's see if we get that same prime factorization. What else equals 12? Besides 1 times 12 again, or 3 times 4, 2 times 6. Okay, at the end of this branch, let's grow an apple because we know 2 is prime. 6, not prime. What equals 6? Right, 2 times 3. So now at the end of all of our branches, we have prime numbers, we have apples grown, we have circles, we're done. And we have, and again, let's keep it organized the same way. Quick glance, you know you have the same numbers. So let's keep them the same. 3 times 2 times 2. Same prime factorization. So it doesn't matter which multiplication fact you start with, you're still going to end up getting the same prime factorization. All right, let me give you one to try on your own. 18. All right, pause the video now. Everyone can try doing the same thing for 18. Then maybe if you want to take a minute and share with somebody around you, find somebody who did it differently and see if you came up with the same prime factorization. All right, let's look at 18 here. What did we do? We could have started with 2 times 9. 2 is prime. Circle it. We're done with that strand. 9, not prime. Anyone remember what it's called if it's not prime? That's right, composite. What equals 9? 3 times 3. We know 3 is prime, so we have 2 times 3 times 3. Okay, what else did we use out there? Three times 6, sure. 3, prime, composite, it's prime, grow an apple. 6, not prime, it's composite, break it up. 2 times 3. And again, quick glance, you see you have the same digits there, the same numbers as your prime So let's write them in the same order just to keep ourselves organized. 2 times 3 times 3. Same prime factorization. Okay. Great job. Let's try a number that's a little bit greater, it has more factors, and then we will see the connection between this and simplifying fractions with 36. One of my favorite numbers to use in math because there are so many factors, so many ways of using 36. All right, so here's another one. Try this on your own, pause the video, and then maybe share with each other or share with the class. And I'll do just one of them to start us off. Okay, so for 36, what do we have? 6 times 6, sure. We know 6 is not prime, it's a 3 and a 2. 3 and a 2, but 3 and 2 are both prime. So here's another one where we want to stay organized. So we have 2 2s and 2 3s. Let's do the 2 2s. I'm just going to put a dot for multiplication. 2 times 2 times 3 times 3 is 36. There's the prime factorization for 36. A list of prime numbers, when multiplied together, equal your given product. All right, so let's say we had the fraction of 12/18. That was your answer to, let's say, an addition problem. You got 12/18, and of course the directions say, write in simplest form or in lowest terms. And you're looking at that thinking, I don't know what I need to do. Okay, well, here's a strategy that will work great. What is the prime factorization for 12? I'm going to write so I have a little more room. The prime factorization for 12, well, we don't have to redo it, we just did it here. 3 times 2 times 2. So let's do it with the 3 times 2 times 2. And again, I'm using the dots for multiplication here. It's just a little bit easier for me to see and focus on the numbers, not the X and for the multiplication symbol. And it means the same thing. And as you go into 6th grade and move on, you'll see the dot is more used for multiplication. What's the prime factorization for 18? 2 times 3 times 3. 2 times 3 times 3. Okay. Here's where the simplifying comes into play. Basically, when you're simplifying, you're trying to group it together so you have less pieces but still show the same amount. So what do they have in common? Well, they both have 2s, they both have 3s. Every time you have one digit on the top, one prime number on the top, you can cancel it out with the same prime number on the bottom. So we have 1 2 up here, 1 2 up here. Cross them off. So you can see it clearly. We have 1 3 here, 1 3 here. Then we have a 2 left over here and a 3 left over here. They can't cancel off because they're the only ones left there. 2/3 is 12/18 simplified. Sorry. Okay, let's try one more together on the other side, and then I'll give you one to try on your own. Okay. 25ths. So we're going to do the prime factorization for 20, and I'm going to put it below here so then I can continue my work up here. What equals 20? Again, any fact that you know equals 20. Because we already proved that any of those facts will get you to the same prime factorization. I'm going to go with 5 times 4. Because I know 5 is prime, and it kind of stops me there. 4, I know that one nice and easy, 2 times 2. So the prime factorization for 20 is 5 times 2 times 2. And I would always do a double check before I say I'm done here. I say, well, let's see, 5 times 2 is 10, 10 times 2 is 20. Yep, that's right. 25. 5 times 5. 5's prime, so I'm done there. 5 times 5, 25. Great. What do they have in common? They both have a 5. So then I'm left with 2 times 2 over 5. Okay, well, let's put 2 and 2 together. 2 times 2 is 4. And 5 remains. 4/5. 20 25ths is 4/5. Great job. All right, why don't you try one? 24/36. Why don't you pause the video now, try this one on your own. And then you can come back for one of the strategies. Okay, so let's take a minute and go through this again. Prime factorization for 24. Notice I'm not doing it right next to my fraction over here, so I can have the space to continue doing my simplifying. For 24, what fact do you want to use? Again, any one works. We know it goes to the same prime factorization. I'm going to go with 4 times 6. It's my favorite fact for 24. No idea why. This is. Okay. 4, not prime, it's composite, but it breaks into 2 times 2. And 6 breaks into 2 times 3. So I know for 24, my prime factorization is 2 times 2 times 2 times 3. And again, I'm going to check this before I just move on and forget about it. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Super. 36. Go with 6 times 6. This 6. 3 times 2. That's 6. 3 times 2. So I have 2 2s and 2 3s. And now we can get to that point where we're doing whatever we can cancel out. Now we have 3 2s up here and 2 here, so we can cancel out 2 of them. 1 here, 1 here, 1 here, 1 here. And we have 1 3 here, 2 here, so we can cancel one of the 3's out. And then we're just left with 2/3 as our simplified version of 24/36. Okay, so far those numbers haven't been too bad. Let's look at the some that are a little bit larger, or when you might have a but what if situation. Okay, so 18. Boy, by the end of this, we'll have that prime factorization pretty much memorized. And some of you are going to catch on and find easier strategies to just kind of remember the prime factorizations or click through them in your head. And that's okay too. But for right now, we're going to be writing them out just so you can prove your thinking and you can keep track of your thinking. So 18. I'm going to start with a fact that I know already has a prime number in it. I'll make it a little more easy for myself. Why not? So I'll do 3 times 6. Oops. Not prime. 6. And then 6 will be a 3 times 2. So 18 is 2 times 3 times 3. And then 40, we'll go with a nice easy one of 4 times 10. Neither is prime yet, but that's okay. 4 is 2 and 2. Don't forget to circle your prime number when you come to the end of it in the strand so you know that you're all set, you're done, you found your prime part of that number. And 10 is 2 times 5. So we have 2 times 2 times 2 times 5. Okay, so here's where we can start canceling out duplicates of the numerator and denominator. We have 1, 2 in the top part and 3 in the bottom, but we can only cancel out 1 because you have to have a partner for each one. And then the 3's, there's no 3's down there, no 5, so we're done. 3 times 3 over 2 times 2 times 5. All right, 3 times 3 is 9. 2 times 2 times 5. Well, 2 times 2 is 4. 4 times 5 is 20. 9 twentieths. 18 40ths simplified is 9 20ths. How about you try this one here? 50 64ths. Greater digits in our number here, but they are still going to follow the same process. Remember, say neat and organized. Keep your prime factorization right below it. Sometimes these are called factor trees. Keep that right below it, and then keep your other work to prove your thinking right next to it. You can pause the video now and come back for the answer. All right, let's look at our prime factorization for 50. Let's start with a 5 times 10 because we already have a prime number. Again, work smarter. Make it easy on yourself. Save the hard stuff for when you need to. So our prime factorization for 50, again, let's keep it organized. Start with the lower digits first. It's a nice strategy to have, and it'll make sure that you are organized. 2 times 5 times 5. Great. 64. What do you want to do? Let's do 8 times 8. Again, make it easier because it's the same thing. 2 and a 4, we got the 2 and then the 4 into 2 2s. 2 and 4, got our 2. So we have a whole lot of 2s. Let's count them and double check, and then we'll check when we write them up here too. 1, 2, 3, 4, 5, 6. And let's just double check because that's a whole lot of 2s. We want to make sure we have the right amount that we did down here. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. So we have 3 4s. 4 times 4 is 16. 16 times 4 is 64. And if you weren't sure, you could do it on the side. 16 times 4. 64. All right, so there's a whole lot of 2s, but we can't do much canceling out there because we only have 1 2 up here. We can cancel that to 1 2 out. No 5s, we got to keep those. So then we're down to 5 times 5 over 1, 2, 3, 4, 5. So it equals 25 over 4 times 4 is 16. No, it's not. 4 times 4 is 16, and 16 times 2. And again, if you need to do it out, that's fine. Just do it off to the side with your other thinking over here. 32. And even though those digits look really large, it is simplified as possible, and we know that because we proved our thinking through this strategy here. That is simplified. So this is a great strategy to use when simplifying fractions, and it will tie into what you're going to do next year. It's always nice to do something knowing that there's a reason behind it and that it will link to something that you do in the future. But staying neat and organized with your work is definitely important.